What is going on, guys? Welcome to your 14th physics tutorial, and in this tutorial I want to explain to you guys the difference between mass and weight. And that is supposed to be an A right there, even though my handwriting is not that great. So a lot of people use the terms mass and weight interchangeably, but the truth is these two terms are very, very different. So let me go ahead and first explain to you guys what mass is. Mass is defined as the amount of stuff inside an object. So all objects, your car, your computer, the pencil you might be holding, they have stuff inside it. A bunch of atoms, particles, a bunch of scientific crap. So technically, when I say how much stuff is inside an object, whenever I say stuff, it's technically called matter. Now, why scientists named it matter instead of stuff? Well, I don't think they thought that stuff was a very technical term. So basically, the amount of stuff or matter inside an object makes up an object's mass. So if you guys are saying, you know what, that sounds an awful lot like weight to me, well, it's easy to get the two confused, so let me go ahead and explain to you guys what weight is now and how scientists use it. Whenever you are referring to weight, now I'm going to go ahead and talk about Earth right now, but it's really any body that has gravity. You can have gravity on the moon, on Mars, on Earth, but I'm going to go ahead and talk about the gravity of Earth right now. So here is the core of the Earth, and of course, since we live on Earth, we have something called gravity that's always pulling us towards the center of the Earth. Now, what weight is that force. How strong is that pull that is pulling you, your body, towards the center of the Earth? The stronger it is, the more that object is going to weigh. So again, whenever scientists talk about weight, they're talking about the force that's pulling an object toward the center of any body. And typically in my examples I'm going to be talking about the Earth, but again you can have weight on the moon, you can have weight on the Mars, so on and so forth. So if you guys are still saying, you know what, mass and weight, it's going to be really easy to confuse the two, well, let me go ahead and talk to you guys a little bit more about weight, and hopefully this should clear something up. So say we were standing on Earth. Here's my beautiful Earth right now, and there's the core of the Earth. Now say we had two people that were identical clones of another. One was standing just on a flat plane, and another was standing on a mountain. Hey, I'm up here. So pretty much the exact same person. Well, if you know how gravity works, the force of gravity is stronger the closer you are to the center of the Earth. So this person right here is going to be pulled towards the center of the Earth with a stronger force than this person right here. So this person, even though they were the exact same person, same size, same everything, this person would weigh more because they are closer to the Earth. And that's another fun fact. Did you know that if you stood on top of a mountain, then you actually weigh less than if you were to stand on the bottom of the mountain or on a flat plane like this guy right here? So the further away you get from the center of the Earth, the less you weigh. So, if you don't want to go on a diet or something, just move to like Denver, Colorado, and you weigh a little bit less. So, or you can, exercise, but who wants to do that? Another thing is, people always ask, why don't physicists use weight all the time? Why do they love using mass? Well, let's go ahead and think about it. Here is beautiful Earth. That must be like Australia, and this is, Canada, yada, yada, yada. Whenever you have an object, such as, actually, I don't want to draw a person anymore. Say you had a big chunk of wood, and this is your chunk of wood right now. That wood would have a certain amount of weight. However, if that chunk of wood was on the moon, then since the moon is smaller, its pull of gravity is weaker, so this block of wood would weigh less. That's why people are able to hop around on the moon, and it looks like they're swimming, because the force of gravity on the moon is really weak, so you only weigh a fraction of what you were to weigh on Earth if you went to the moon. So obviously we can see that even though this object and this object are the exact same, whenever we try to take its weight in different places in the universe, its weight can change easy. However, its mass, on the other hand, is consistent. The same amount of stuff in this block is going to be there whenever we put it on the Earth, on the moon, on Mars. the amount of matter inside that object, or the amount of mass, is going to be consistent no matter where you are. So that's why physicists prefer mass instead of weight, because if you took an object and move it from Earth to the moon to Mars, its weight is going to fluctuate, so you can never really get a good understanding. However, its mass is a better, I don't know, it's just a better way to measure things because it's more consistent no matter if you're on a mountain, on the ground, on the moon, on Mars, mass is going to stay the same. So again, on Earth, because gravity is usually the same, mass and weight are indeed related, but for the purposes of physics and the rest of these tutorials, I'm going to be using mass because it's basically better than weight. No one ever complains that they need to lose mass for the New Year's, and that's another reason. Did I just write way right there? That's embarrassing. So anyways, I've been talking for way too long, so I'm going to go get a drink of juicy juice, maybe grab a juice box or something, and I will see you guys in the next lesson.